Continuing on in section 5.2, we have the take note with graphs of direct variations on page 303, which I have here as well. It's a concept summary. So here it shows two different situations for direct variations. So the graph of direct variation equations, y equals k times x, it's a line with the following properties. Every single time it goes through 0, 0, and the slope of the line is k. In example 4, writing direct variation from a table. For the data in the tables on page 303, which I have here, does y vary directly with x? If it does, write an equation for the direct variation. So in order for them to vary directly, our k value has to be the same. Okay, that's the definition of direct variation, is that every point has the distance between every point has the same slope. So if we can write these as direct variation equations by comparing our x and y to find our k values, if our k's are all the same, then yes, it's a direct variation. So remember that direct variation is y equals k times x. So we're comparing our y values to our x values to get our k value. So it's the ratio of y to x. It's our slope, which remember is rise over run, y's over x's. So to find our k value, we take y divided by x. And I'm going to do that for each one of my points. Y divided by x, y divided by x, and y divided by x. I'm going to reduce them down. Here I can take a 2 out of each and I get 3 over 2. Here I can take a 4 out of each and I get 3 over 2. And here I take a 5 out of each and I get 3 over 2. Since all of these equal each other, then yes, it's a direct variation. And if it does, write an equation for the direct variation. Well, k equals 3 over 2. Because they're all the same. So now that I know my k value, I can plug that into my function to relate x and y. So y equals 3 over 2 times x. Same idea here in B. Again, we want to know, for the data in the table, does y vary directly with x? If it does, write an equation for the direct variation. So here, I'm looking for my k value. And remember, k equals y over x. It's my slope. Slope was y's over x's. Here it's y over x because we're talking about one point. So I take all my y values and put them over my x values. Y over x. Y over x. I'm going to simplify here if I can. So here I get negative 1.6. Here I get 2.4. And here I get 0.4. Those are not equal. So this is not a direct variation. Again, it's not a direct variation because in order for it to be a direct variation, my ratio of y's to x's has to be the same every time. Here it's not. If we plugged those in and found our k values, which is what we just did, we would not get the same thing. So it's not a direct variation. There is no k value. Now, for the data in the table on the bottom of page 303, does y vary directly with x? If it does, write an equation for the direct variation. So again, here, in order to determine if y varies directly with x, we need to find our k value for each point. Y equals k times x. So if I solve for k, we get y over x equals k. And remember, k is like our slope. So our slope is y's over x's. K is y over x. So here I'm going to take all of my y values divided by my x values and reduce. So I took y divided by x for each of them. Simplify them down. Here I get negative 0.75. Here I get negative 0.75. and here I get negative 0.75. And I know usually we leave those in terms of fractions, but since I had decimals in my fractions, I took them just to decimals to kind of look at here. But we can write those back as fractions, which is what I'm going to do here, because these are equal, which means, does y vary directly with x? Yes. If it does, write the equation for the direct variation. Well, 0.75 is the same as 3/4, and it's negative. So k equals negative 3/4. Once I know that, and again, we can see that from right here. Once I know that, I can plug it into my formula. Y equals negative 3/4 times x. So again, we take, for y to vary directly with x, we have to have that constant of proportionality here, which is y over x. So we found that for each point, they're all the same, which means it is direct variation, and we can make our equation. Quick recap here. If the ratio of two variables is constant, then the two variables have a special relationship called the direct variation. The graph of a direct variation equation, y equals k times x, is a line that passes through 0, 0 and has a slope of k. And that's all I have for section 5.2.